We'll be doing Unit 2, Day 1. It's Unit 2 is a very short unit. We're going to try to finish it within 3 days, but it also has a lot of content that we have to make sure we remember. So the first part, Unit 2, Day 1, is notes on conditional statement and biconditional. Conditional statements and biconditional. And one thing you guys gonna find out is when we are done with this unit, you're gonna probably feel like we were actually in an English class versus in a geometry class. But logical thinking is part of math way of thinking, and it is included in a geometry section of math. So you're learning, how to write a statement, how to say if a statement is true or false, and things like that. So the first learning target we're working on right now is I can write a counterexample to prove a statement is false. Okay. All right, so we have to go by step. So the first one we're gonna talk about is what is inductive reasoning. And day 3 notes would talk about, or day 2 notes will talk about deductive reasoning. So what is inductive reasoning? It's a reasoning based on patterns, okay? So I'm using this new tablet, so it's kind of hard to write a little bit. So when you look at a pattern and you come up with your reasoning, for example, if I gave you 2, 4, 6, and I ask you, okay, what's the next number? You look at, oh, these are the even number, or it increased by 2. So you say, oh, the next number is going to be 8, right? So that kind of conclusion or reasoning you're going to come up with is called pattern, okay? In geometry, we don't use, we use conclusion, but also a conjuncture is the same thing as a conclusion, okay? So a conjuncture is a conclusion you reach using inductive reasoning. So sometimes you see the problem. What's the conjuncture? You come up based on the statement, and then you look at the pattern, and he said, every Monday we serve pizza. And then the statement will say, today's Monday. Then he said, oh, then we're going to serve pizza. And so if somebody come and ask you, how do you know? You can say, oh, it's inductive reasoning. I look at the pattern, it's Monday, therefore we're eating pizza today. So those kind of reasoning is called inductive reasoning, and the conjuncture you come up with is the conclusion part, or your conjunction. So when it comes to counterexample, okay, that's the next definition we're going to go over. It is an example that shows the conjuncture, whatever conjuncture you come up with is false, okay? And you can come up with any true statement that if you can find one example where that statement is not true, that means you come up with a counterexample. That means that statement is false. So what is the counterexample for the following? So if somebody make a statement saying, if the name of the month starts with January, then it's a summer month, okay? Oh yeah, you're right, it's June, July, but is it always in all of the 12 months, all of them starts at J are in summertime? You can say no, right? What starts with J that is not a summer weather? January, good job. So January is the month that we can say no, that is not true. January is a winter weather, right? So it's not a summer month, it's a winter month. So that's something that you guys can come up with. Another statement will be all four-sided figures are rectangles. You can say no, what about a square, right? And or what about a paragraph? What about a kite? What about this? So you can come up with reasons to make that statement false. That example you're coming up is called a counterexample. So to make it in math, the sum of two integers is always positive numbers, right? The sum of two integers is always positive. -1 is an integer, -2 is an integer, right? Is -1 plus -2, is it positive? No, right? So that's the way you can make that statement false. This would be your counterexample. okay? All right, the next definition we're going over is negation. And I know most of you are military family, and you probably heard from your parents, negative. It means no, right? And it's the same thing. It's the opposite. So negation is not always the no part. The negation or the opposite of the statement is, and in geometry, instead of writing not, we use the symbol, okay? The wiggly line. So if I put it in front of a statement, or a letter that says not that statement, okay? So what would be the negation of I am going? Okay, I want you to negate that. So I am going is going to change into I am not going, right? So that's going to be your negation. What if the statement already has a not in it? I am not awake. What's the negation of that statement? I am awake. Very good. Without the not. So deleting the not piece make it negative. So that's why we like the word opposite, okay, versus always. It's not always adding not, you know, like in even in math, when you have two negative together, it changes into a positive, right? That's what you end up with. I'm not awake, meaning I am awake, right? So that's the definition we want you to remember about negation. All right, the next part we're going to go over is, it kind of include 3 learning targets, and they're all included here. The first one will say, I can identify the hypothesis and a conclusion of a statement, and in any conditional statement, and you should be able to write the inverse, converse, and contrapositive of a statement, and then represent those statements into a logical symbolic notation, conditional statements. So we're going to go by, breaking it down. So we're going to start with a conditional statement, because it says here, I can identify the hypothesis and the conclusion of a conditional statement, right? So what is a conditional statement? Okay, that's the first thing we need to understand. What is a conditional statement? It's a statement that has 2 parts, and we use if and then to connect those 2 parts, okay? It's going to have a hypothesis. That's the first thing you're going to see. The first statement that follows the if is going to be the hypothesis, and it's going to have a conclusion, okay? So a statement that has a hypothesis and a conclusion is called conditional statement, okay? So in this problem here, in example 1, and you understand it more when we start going, this statement has, if it is noon in Virginia, then it is 9 a.m. in California. See how there are 2 statements in it? The first one is, if it is noon in Virginia, and then I have, then it is 9 a.m. in California. Okay, that is my conditional statement. So every time you see 2 statements combined, especially if they're combined with if-then statement, then you're gonna determine, oh, this is gonna be the P. The first one is gonna be your P, and the second one is gonna be your Q, the second statement, okay? So the first one is, what is your P? Is it is noon in Virginia. I'm not going to include the if, okay? It is in VA, right? I'm just going to make it short. So it is noon in VA is the P part, the first part of the statement. And the second part, or the conclusion, is it is 9 a.m. in California. Okay, so 9 a.m. in California is what we have to write. So this is called a conditional statement. So in any statement, you would be asked, okay, what's the hypothesis of the statement? What's the conclusion of the statement? Every time you're given that, is in this example, it says underline the hypothesis and circle the conclusion. So whenever you have to underline, just make sure you look at, okay, what is the statement that follows the if, okay? So let me use purple for my hypothesis. It says underline it, so I'm underlining it, okay? This is everything that follows if is going to be my hypothesis. Everything that follows the then is my conclusion. And they want you to circle it, right? The conclusion. So we're just going to circle it. So it does not include the if, or it does not include the then. You always have to make sure you don't include them, okay? Cross that out, and I'm crossing that out. Okay, what's the hypothesis? An angle measure more than 90 degrees and less than 180 is the hypothesis. Conclusion, oh, it's an obtuse angle is your conclusion. Okay, so I want you guys to try to do number 2, underline the hypothesis and the conclusion, and we'll go over it in class, next class. So this is the same thing here with example 3, but the only different is it's not your traditional if-then statement. So the A is given if two points are collinear, if they lie on the same line, right? So you don't see the if at the beginning, but you see it here, okay? You see it here. So it says make a conditional statement from statement not in if-then form or not traditionally in if-then form. So the way I would start is, okay, I can say if they, sorry about that, lie on the same line, then I will write the conclusion in red, then points are collinear, right? Are collinear. Okay, so this is how you would write it. If they lie, because they already gave you the if part here, right? So I know anything that follows if is always the hypothesis, so you can change it that way. But when it comes to this kind of statement, right? All fish swim. Oh, which one is, I mean, this is kind of easy. A number is divisible by a number divisible by 9, that is one part of the statement, is also divisible by 3. So you can kind of break it down this way. But here it's kind of hard to break it down, right? All fish swim, but you can't. The fish part and the swim part can be separated. And then you can write the statement as if, and if you want it to make sense, like when you're to write a proper English, you can say if an animal is a fish, or if it is a fish, right? Then you can say, then it can swim. Okay, that would be your conditional statement. You wrote it down in if-then form. Okay, so just make sure you take the time to understand this. So, and you guys go ahead and do C, and then we'll talk about it in class. So the next part we're going to go over is our converse statement. Okay, so now we know conditional. Now we're talking about converse. Converse of the original conditional statement is symbolized. So remember, the conditional statement is given as P arrow Q. I don't know if I went over that in this page, but it was right here. Sorry, guys. So this is the symbolic notation of a conditional statement. If P, then Q. So the first statement is P, the second statement is Q. When I'm doing the converse of that statement, I am switching the order of it. Okay, converse is Q, then P. If Q, then P is what I'm writing. So if you guys notice, converse starts with CO. So if you wanted to, because you kind of would get it mixed up towards the end, trying to remember that CO starts with CH, which CO starts with C and O, right? So the C represent change, okay? Change order. And the O part represent order. Okay, so changing the order of the statement. So it initially was PQ, we changed the order, now it becomes QP. So in this case, so we wanted to write the converse of the statement. So it says here, if it is my geometry textbook, then it is blue. Okay, what is the P part of the statement? It is my geometry textbook. What is the conclusion of the statement? It is blue. Now I have to switch Q first, right? So what I'm going to write here is if it is blue, right? Then I'll write the P, which is then it is my geometry textbook. Okay. Okay. That what I just wrote my statement, the converse of the statement. Okay. The next one is asking you to write the inverse. Okay, the inverse. So you're going to look at the first conditional statement that has P and Q, right? That's the first conditional statement. When you do the inverse, you're negating both. Negating the hypothesis, negating the conclusion. So insert not starts with IN. It means insert. Inverse starts with IN. It means the I represent insert not. Okay, or negate the whole statement is what you need to do. So this one is the easy one because all you do is make it opposite. Okay, so it says here, if it is raining, then practice is canceled. And the one thing you guys need to remember is you putting the not or the negation in both. Okay, the hypothesis and the conclusion. So you're going to put if it is not raining, so I'll just symbolize it, raining, then practice, abbreviated is what I'm trying to say, so that I'm not, practice is not canceled. Okay, so that's what you have to remember. If it is, sorry about that, I went too far to the end. So if it is not, if it is not raining, then practice is not canceled. Okay, that's what we have to do. All right, and then the contrapositive is when we do both. We flip and we negate. Okay, so we're doing both the inverse and converse of the statement. Okay, this is the original one. See how we flip it? It was PQ, now we have QP. It was positive, now both have to be negative. So the contrapositive is the longer one. It has a C or an O and an N. That means change, order, and negate. That's what I have to do. So I have to change order and then I have to negate the statement. Okay, so I know I don't want to pass 20 minutes, so I'm just gonna try to finish this very quickly. All right, so in this case it says if we were in Virginia, then we are not in Texas. So I have to negate if we are not in Virginia, then we are. So I have to delete the not part. And then I have to put the Q to here and the P to this side, right? So my statement is says if we are in Texas, then we are not in VA. Okay, that is making it the contrapositive of the statement. Okay, very well. So we will do most of the examples in class, but we have examples here 4 and 5. If you guys wanted to continue working on it, you can do it. But one thing I wanted to add before we end is if I have a statement, an original statement is, so this is the part that I want you guys to pay attention to this piece on this side. If an original statement is true, then only the contrapositive is true, okay? And that's one thing we were supposed to go over is a biconditional. A biconditional is a form by joining the two parts of a conditional with if and only if. Okay, 20 minutes. So I'm gonna stop.